How do tiny manufacturing defects cause electronic recalls? Imagine holding a tiny piece of a puzzle that seems insignificant but can cause the entire picture to fall apart. Small manufacturing flaws in electronics work the same way. Even the tiniest defect can lead to big problems down the line. During production, components like circuit boards, solder joints, and capacitors are assembled with precision. But sometimes, tiny cracks or poor connections sneak in unnoticed. These microcracks in printed circuit boards can happen from rapid temperature changes or mechanical stress during assembly. They might be invisible during initial testing, but can cause open circuits or intermittent connections once the device is used. Poor solder joints are another common culprit. If a solder connection is not solid, it can cause a device to fail intermittently or not work at all. For example, a smartphone charging port with a weak solder joint might stop charging after a few months. Using low-quality components like capacitors that degrade quickly under electrical loads also increases failure risks. These tiny defects often start small but can quickly cascade into larger issues. Overheating, short circuits, or complete loss of function can happen because of these minor flaws. When enough consumers report problems or warranty claims pile up, manufacturers often discover these hidden defects. Once identified, recalls are issued to prevent harm and meet safety rules. Recalls are costly and can hurt a brand's reputation, but they are necessary to keep consumers safe. To avoid these issues, manufacturers use strict quality control measures. They inspect components with advanced tools like X-ray machines or automated optical inspection systems to catch microcracks or faulty solder joints early. Designing products to withstand real-world stresses and testing them under simulated conditions also helps. These steps ensure that tiny manufacturing flaws don't turn into big failures after the product hits the market. Troubleshooting electronic failures often involves understanding how these small defects originate and spread. Knowing this helps engineers improve manufacturing processes and product designs. In the end, controlling tiny manufacturing defects is key to making reliable, safe electronic products that last longer and keep users happy.